The third video, it's the continuation of question number 3. We discussed the first part. Now we move to the second part. The word has letters, not all distinct. And then we need to form the word which has all the vowels together. That's the second part in it. All the vowels are together. It's all the vowels are together. So how many vowels do we find here? We have the two A and one I. The all things that is to be together, we consider it as one unit. And then we take up the remaining element that is to be arranged. So that is the two C's, two L's, two S. This is the element that we have to arrange. So when you arrange this element, we are arranging it in such a way that we treat it as one unit. This is second, third, 4, 5, 6 and 7. So how many units are to be arranged? The number of units, the task that you have is, the first task is the arrangement of, it's the arrangement of 1 plus the 6 units. I've divided it into different units. So these are 6 units plus 1 unit. So in how many ways they can be arranged? That is possible with the number of elements that you have, that is 7 factorial. And in this 7 factorial, what you find is there are 2 C's, there are 2 L's and the 2 S. We are considering it as 1 unit. So we don't need to take up its arrangement now. That's the second task we have. So with each of this arrangement, what we have is that there is another task that you have to do. With each arrangement, you have to arrange. It's the arrangement of the AA and I. It's arrangement. In how many ways this can be arranged? This can be arranged in 3 factorial ways. But when you arrange it, you'll find that there are 2 A's. So we'll have to take into consideration the arrangement of the 2 A's. The number of ways that we can arrange the 2 A's and I is 3 factorial upon 2 A's. Therefore, the total words formed are, as per the principle of counting. It's a principle of counting. What does it say? The total number of ways the two tasks can be done is multiplication of that. So it comes out to be 7 factorial upon 2 factorial. You can compile it and write multiplied by 3 factorial upon another 2 factorial. So the total number of 2 factorials that you find is divide 4. So is there any simplification that you see in this? There is no simplification. So do not go for any further simplification. This is the answer. You can leave this answer here. So when you're writing it, you know what the expression will be. So accordingly, you write the answer in the compiled form. No need to express as 2 factorial 3 times and then another 2 factorial for it. So you have already seen that there will be 2 factorials in the denominator. Compile it and write. So that's how we'll answer the second part. Now the third part of it. The third part of it says that no two vowels to be together. So how do we discuss such case where you cannot have the two vowels together? When the two vowels are not together, if you remember what I explained was, you fix up the remaining elements. The remaining elements are the 6 consonants that you have. So how many consonants are there? There are 6 consonants. C1, I'll express it in terms of the C1, C2. C1, C2, C3, C4 and C6. Fine. So now what you do is the cross mark places. First you find out how many places you can keep the vowels. So what is the first task that you have? The first task that we have is to fix up the position for the first task. First task. It is arranging the vowels at which places? At the cross marked place position, at this position. Fine. So how many positions do you find? 1, 2, 3, 4, 5, 6 and 7. So we have 7 positions for the 3 vowels. So in how many ways you can take up this arrangement? There are only 3 vowels. So it is 7p3 upon why upon the 2 A's. It is divided by 2 A's. What is this meant for? This is meant for the two A's. Fine. Now we have settled the matter for the vowel. Now what's the second task that we have? We have the arrangement of the consonants. So where are the consonants? That's the second task that we have. The second task is the arrangement of the consonants In how many ways they can be arranged? It is the number of ways they have, that is 6 elements are there. They can be arranged in 6 factorial upon the 2 factorials of the C's, 2 factorials of the S and 2 factorials, that is there are 3 2 factorials. So together it can be. Therefore, total words formed as per principle of counting is 7p3 multiplied by 6 factorial upon factorial 2 to the index 4. So that's how we take up this question, right? So now we move on to the fourth part. The fourth part of it says that there has to be 2 or 4 letters between the two S. The fourth part of it is there has to be, the fourth part is 4 letters between the two S. So first is, let us now analyze how to take up. We have a 9-letter word, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9-letter words and you need to have 4 letters between the two S. So wherever the S are, you will always have to insert the 4 letters. So that means we'll have to keep a space of 4 blanks between the two S. Now that means the S can be kept at the first position. If S is kept at the first position, the second S will be kept at it will be kept at the 6th position, because 4 elements are there first and this will be 6th position. Likewise, what do you find? We can displace the S. We can keep the S in the second position. If S is in the second position, the S will shift, the second S will shift to the next position. S in the third position and S in the fourth position. Now, can you go further? That is, can you shift this S to a further position? We cannot, because you find that if you keep an S on this 5th position, will not have the space for the next S. If you keep it here in the 5th position, and then automatically the S that you have is a choice here or here. So you won't be having 4 elements in between them. So these are the only 4 options that you can have for the 4 elements to be between the two S. So now we have divided it into tasks. Task 1 is, the first task is the positions of the S. How many positions you find that? We have 1, 2, 3 and 4. It is 4. There are 4 positions for it. Now second task is, what is the second task? The arrangement of the remaining letters. What are they? How many are there? The remaining are 7, and of the 7 there are 2 C's, 2 L's and 2 A's. The 2 S has already been considered. So that is it. Therefore the number of words that will be formed will be, the total number of words formed will be, the total words formed is, it is 4 multiplied by the 7 factorial upon 2 factorial to the index 3. Now here you find that there is a simplification possible. The 2 factorials 2 times will get cancelled with it. So final answer will be 7 factorial upon 2 factorial. So that's how we leave the answer. Thank you.